This is Chapter 5, Section 3, the force of moving water. So the first thing we're going to talk about is energy. And energy is the ability to do work and cause change. Or in your notes, you're going to put the ability to cause change and do work. So if you don't have energy, you're not going to be able to cause change. There are two kinds of energy. There's potential energy and kinetic energy. Now, we learned these in elementary school, so these are not new terms. You'll remember that potential energy is energy that is stored and waiting to be used. I like to think of it as I store things on pots on my counters, and so that reminds me of potential energy. Or I might think, oh, that child has so much potential, but they just don't use it. That means they're storing their abilities instead of using them. And then the second type of energy is kinetic energy. And this is the energy of motion. A good way to remember this is there's a game console out there called Kinect, and that you have to use motion in order to play the game. So water has this type of energy, and it converts back and forth from potential energy to kinetic energy by the force of gravity. So gravity pulling water down a slope is going to cause water to go back and forth from potential to kinetic energy. Anytime the water is moving, it has kinetic energy, and anytime it's stored and waiting to be used, it's going to be potential energy. So what happens to energy when it does work? Well, it is transferred from one object to the next. So when we're doing work, we're going to transfer our energy from our body to moving our pencils, or from our bodies, inside our bodies, to moving our feet and going across the floor, or lifting the shovel. So we're transferring our energy from our bodies into that object. Well, the river does the same thing. The river can do work as well. It can move sediment, it can shape the land, it can cause weathering. So sediment gets into the water. Usually this is common sense type things. If you ask yourself, how would dirt get in water? It can wash or fall into the river. It can erode from the sides or bottom, or it can be dropped by wind. There could be other reasons, actions of animals, people pushing it in with bulldozers. Abrasion we learned with weathering, and this is the wearing away of rock by grinding action. Sometimes water carries sediment, and when it carries that sediment, it kind of uses it like sandpaper, and that sediment can brush against other objects and cause the wearing away of the riverbank or other objects. So, load. This is the amount of sediment that a river carries. You might ask, another person, what is the load that you're carrying? Boy, that's a big load you're carrying in your book bag there, meaning that's a lot of stuff that you have in your book bag. Well, a river has load as well, and that's the amount of sediment that's in that river. So, what affects how fast the river flows and how much sediment it can erode? Well, that's going to be determined by the river slope. The steeper it is, the faster it's going to go. The volume of flow, the more water it has, the faster it's going to go. And the shape of the stream bed. If it's deep and wide, it's going to go faster than if it's shallow and narrow. So let's look at those into detail. So remember, the steeper the slope, the faster the water. So slope is affected or affects river flow, and when we say number 10, I'm just kind of referring back to the last question. It affects how fast the river flows and how much sediment erodes by the steeper the slope, the faster the water. River flow is the volume of water that moves past a point on the river at any given time. So what I'm saying here is that river flow is measured. We measure a river's flow by how much water goes past this area in a point in time. And so if we're testing, okay, let's see how much water goes past here in 5 minutes. We're measuring that river flow. And sometimes the river, like maybe after a flood, is going to have more river flow than during a drought. And so river flow is a measure of how much water flows through a certain area in a period of time. So how does this affect the speed of the river and the amount of sediment it can erode? Well, the more water you have, the more speed it has and the more load it can carry. So the volume of water, you can have a little trickling stream and it's not going to carry much debris, or you can carry it in the you can have a deeper river and it can carry a lot more particles and a lot more sediment, and it goes a lot quicker. So you're not going to get swept away in a creek, but you can get swept away in a river. Friction is the force that opposes the motion of one surface as it moves across another surface. You can feel friction when you rub your hands against each other. You also have friction with the floor, which allows you to walk across the floor. If your shoes didn't have friction, or we could say traction with the floor, and then you'd be slipping and sliding, not really getting anywhere. It's kind of like walking on ice a little bit. So we use this term friction when we consider rivers because sometimes the water has a friction with the bottom of the stream or the bottom of the riverbed or the sides of the riverbed, and that can slow down the water. So if it's a narrow and shallow river, then that's going to increase the friction and slow that river down. But if the river is deep and wide, then there's less friction and that river is going to go a lot faster. So remember, shallow and narrow, it's going to have a lot of friction, go slow. Deep and wide, it's going to go a lot faster. And then the last vocabulary term that we're going to learn in this section is turbulence. And this is when the water moves every which way. Sometimes you'll see movies or be on a plane and the captain will come on and he'll say, have a seat, we're about to experience, and put on your seatbelt, we're about to experience some turbulence. Meaning they're getting into some air that's kind of going every which way and it's going to jostle the plane a little bit. It's not anything that's dangerous. The plane is built to handle this kind of turbulence, and if it gets to a point where it's too much for the plane, the pilot will descend or increase its altitude to get out of that turbulent weather. Well, a boat can also experience turbulence. Not waves, but really that kind of back and forth, up and down, all around type motion of the water. Maybe like in whitewater rafting, you're going to have a whole lot of turbulence. And that's when the water moves every which way.